We're going to look here at the reactivity of halogens. Now the halogens is a group on the periodic table. It's group 7 on the periodic table. We've got periodic table over here, let's just quickly have a look at it. Okay, so the halogens is this group here. It's group 7. Fluorine, chlorine, bromine, iodine, astatine. All non-metals, famous for the fact they're incredibly reactive non-metals. In fact, they are to the non-metals what the alkali metals are to metals. The alkali metals are over here on the group 1 of the periodic table. Lithium, sodium, potassium, rubidium, cesium and francium. Very reactive metals here, group 1. Group 7 here, very reactive non-metals. Now for group 1, the alkali metals, we looked a lesson or two ago and in a previous video about why they increased in reactivity as they went down the group. Now for the halogens we have to do exactly the same, we have to explain the trend in reactivity as they go down the group. Now as we go down the group of halogens, they get less reactive. Okay, so the reactivity of halogens, less reactive as they go down the group. So fluorine at the top is the most reactive, go down the group. So the most reactive non-metal on the periodic table is fluorine. The second most reactive, chlorine, then bromine, then iodine and astatine. Astatine is the least reactive there. Okay, so why is fluorine the most reactive? That's what we're going to look at here. Okay, so to do that, let's wait for this to come back into focus, if we can get it back into focus. That's better. Right, so to do that, we have to draw out the electronic configurations of fluorine and chlorine. Okay, so let's do a dot for the nucleus. The nucleus contains all the protons, and fluorine's nucleus contains 9 protons. So 9 positive charges in the nucleus, which must mean there's 9 electrons, 9 negative charges on the shells on the outside. Okay, so hopefully here you can see fluorine's in group 7 of the periodic table, so it's got 7 electrons on its outer shell. It needs 1 to fill its outer shell. 2, 7, there's our electronic configuration. Chlorine, dot for the nucleus, it's got 17 protons in the nucleus, therefore it's got 17 positive charges, so it must be 17 negative charges to balance those out because all elements are neutrally charged. And of course electrons are negative, so there must be 17 electrons. 2 on the first shell, 8 on the second makes 10, which must make them 7 on this outer shell, which shouldn't surprise us because this is group 7 of the periodic table. The group number always tells us the number of electrons on the outer shell. So that electronic configuration 2, 8, 7. Now if you remember correctly when we explained the alkali metals reactivity, our opening statement was atoms are more reactive, it's easier for them to get a full outer shell of electrons, and that's the same here. Okay, so atoms or elements are more reactive if it is easy for them to get a full outer shell of electrons. Now fluorine is more reactive here, so why is it easier for fluorine to fill this outer shell? Okay, the answer is as follows. The nucleus is positive. We've said that. The nucleus contains all the protons. Next one, the electron that needs to be attracted is negative. Okay, so we need to put an electron in there. That electron is negatively charged. The nucleus is positively charged. It's the nucleus that's going to be pulling that electron in. The electron that needs to go there to fill this outer shell of the chlorine is negatively charged. The nucleus is positively charged. The nucleus is positive charged. It's the nucleus that's going to pull that extra electron in. So it's easier for fluorine to pull that negative electron than it is for chlorine to pull that outer electron in. Why? Well, the vacant space on the outer shell here is closer to the positive nucleus. Okay, so the vacant place for the extra electron is closer to the nucleus on fluorine, so it is more strongly attracted. And that makes it more reactive. Okay, you could also say there is less shielding from inner shells on fluorine. That also makes it easier to attract that extra electron there. So it's easiest for fluorine to get to fill its outer shell because the vacant space is closer to the nucleus. And that's why fluorine is more reactive. And that's why they get less reactive as they go down the group, because this vacant place gets further away from the nucleus every time. And that is all we need to know about that.